Hello everyone, my name is Ethan. I am a part of Team Stingray, and this is a recreation of the Create Your First Game in Godot Engine workshop from UTS Tech Fest 2024. We went over the recording from that workshop and the audio was a little bit off, so we've decided to create a whole new version which covers all the same content and then also completes the stuff that we didn't get to complete on the workshop. As such, I'll probably be talking a little bit faster than I was on the day, but just feel free to pause and to go back and just, go back over anything that you might find confusing and take it slow. That's perfectly fine. Yeah. So just to go over the slides, who we were, I'm Ethan. I'm in the first column here. I work on technical art, UI, and programming, and the other members of Team Stingray as well were there, Xander, Tom, Lauren, and Alex. Team Stingray is a collective of third-year Bachelor of Games Development students at the University of Technology, Sydney, and we love making games. More importantly, we love making Godot games. So just to go over the games we've made a couple throughout the course of the summer, and we've also made Arcane Raiders, which you'll hear about later. But the common thing between all of these is that they were made using the Godot engine. But what is the Godot engine? Quite simply, it's a game engine, but more importantly, it's open source. What does that mean? Well, most software is closed source, which means that the code that was used to create the engine in the first place is closed off. So often the developer will give you a product, and you can't really do much with it. You can only do what the developer wants you to do with it. You might be able to modify it a little bit, but by and large, it is in the hands of the developer what you can and can't do. Godot is unique in that it is open source, so all of the original source code used to write the engine is available to see and modify up to your content. You're more than welcome to add features, fix bugs, optimize the code, and even submit that to be a part of formal updates, which is really cool. It can work in 2D and 3D, so we're going to be making a 2D game today, but it should be noted that an entire game can be made in 3D as well. It's very lightweight, so it makes it really easy to make applications as well as games. It can be used for a variety of different purposes. In the past, it's been used to create an application that can make 3D materials or operate stream overlays for online streaming. It can do a whole bunch of things. And there's a couple games that have been made using Godot. So one of them is Dome Keeper. And then recently it was announced that Slay the Spire 2 will be made using the Godot engine, which is really exciting to see. What are we doing here today? Very simple. We're going to be creating a little platformer game. There we go. It's just loading. So you'll be playing as a little alien guy who will be able to run around and jump, collecting coins, which will affect your score in the top left. And then you'll be able to hit the flag, which will end the game. We'll also worry about losing the game, so when you hit the enemy, you'll lose. And then when you fall out of the world, you'll lose as well. So it's very, very simple, but it is a great launching point to creating your own game. Alright, let's get started. So in the description of this video, there will be a link to a Google Drive folder, which you're more than welcome to download, and that will create a zip file, which I've placed here. So in this zip file, when you open it and extract it, you'll get this folder here, which contains the entire engine in one executable, as well as the assets that we'll be using throughout the workshop. So feel free to just drag the Godot engine onto your desktop. You can put this anywhere. And then you can just double click to open the Godot engine. Now yours will say blank. I've got a whole bunch of projects already here. Yours will be blank, and that's okay. The first thing we're going to need to do is create a new project. So let's create a new project by pressing the new button. And it's going to prompt a name for us. So let's just name it something simple like My Awesome Platformer, or you can name this whatever. It's your game. And then the Godot engine will give us an error here. The Godot engine wants us to use a new folder. So let's hit Browse. And you can store this anywhere, so I would recommend storing it on the desktop, but I'm going to store this in a special folder. You can pop this anywhere. You could just hit create folder, which creates an empty folder. Let's say my awesome platformer again. Right, we can select the current folder. So now that we've selected a blank folder that has nothing in it, the engine says, yep, not a problem, we can use this. Another thing that we can have a look at is the renderer. So there are three main renderers in Godot: Forward Plus, which is the most advanced advanced renderer, which is used for desktop applications, mobile for mobile devices, and then Compatibility, which is used for websites and lower end hardware. We can change this renderer at any time, so just go with the one that it recommends you. It'll probably be the Forward Plus one, and just hit create and edit. Awesome. So this is a new project, and you'll see immediately that this is not a 2D view. It's actually a 3D view, and we can move around, and we can, shimmy the camera, but this isn't quite what we want to make. We want to actually make a 2D game. All right, so how do we switch from this 3D view to 2D? Well, in the top here is our windows. Right, in the top here is the windows. You'll see that the currently selected one is 3D, so we could just switch this to 2D by clicking it. Cool. We'll now see like a 2D plane, and then this rectangle here, which shows the default camera. So when we create our game, anything in this screen here is what will be shown on screen. We also have the script window, which is a little bit blank because we don't have any scripts available right now. And then the asset library. So we're not going to be using any of the assets made, but I just wanted to show it off here. There's a whole bunch of user-made assets that we can just click and install directly into the engine. And it makes it really easy to create, to use pre-made code in our own projects. And that's perfectly fine to do. Let's switch back to 2D. Another thing we're going to be worrying about for now is the file system. So in the bottom left is our file system dock. This stores all of the saved files on our computer. So this includes any audio files, any sprites and 3D models that we might be using. We're not going to use any 3D models, but this is where they'll be stored, as well as any scenes, which we'll discuss later. You'll notice that the only thing it gives you is the Godot icon itself. If I double click it, we can see it's just an image. That's all it gives you to start. Cool. Let's start our project by first popping all of the assets into the engine. So if I can simply keep both these open. I can just grab this and drag it straight into the file system. And we'll see that it's automatically loaded. So it's loaded all of the stuff that we've created already. For ease of access, I'm going to right click and select the folder, and I'm going to make it a nice yellow, just so I know what has been pre-made for me and what I've made myself. Alright, let's just explore what's in our assets real quick. So we have made a couple assets for you. So we've created a sound effect for picking up a coin. Lovely. We've created a bunch of sprites, so we've got a bunch of character sheets, which we will use to animate the character when they move, and then also a bunch of still sprites, which is just a very simple still, just for when they're not moving. We've also got tiles, so these will be used to create the environment really, really quickly. And then we've got a coin and a flag PNG. Awesome. Let's start by creating our first scene. So this is really core to Godot, the difference between nodes and scenes. So if I switch back to my slides real quick, what is the difference between a node and a scene? Now this is the core of Godot, as I've just mentioned, but I should probably explain what they are a little bit further. So unlike other engines which use a component system, Godot uses a node system, where each node has one job. So this can be used to, if you look at the list, display a sprite or play a sound. It can be used to detect collisions or run a custom script with our own behavior. All of these are stored in one tree, which are all bundled together and saved as a scene. So a scene is stored in the file system, which we've already seen, and this is basically a blueprint where we can drag and drop the scene into any other scene to create a bunch of nodes that we've already created. Now I know it's a bit confusing off the top of the bat, but soon it'll become really clear on how to use them, especially when we start making our own. Basically, a scene contains a bunch of nodes, and then we can instantiate a bunch of nodes in a scene. So let's worry about that now. Let's start by creating our player. We're going to use the scene tab to create our player. And we're not going to use any of these at the moment. We're going to hit other node. And you'll see all of the nodes that Godot allows us to use. Now we can open up all of each individual folder and we can look through them. The one we're actually going to be using is character body, because our player is a character. And as we highlight the node, we can see down the bottom that Godot has given us a hint as to what the node does. And we can see that it is a 2D physics body that has been specialized for movement via script. So just to dumb that down a little bit, it is a physics body that is specifically for player input. And that makes it really easy to see what we want to make. So let's select character body and let's hit create. And we'll see already that a few things have changed. So these buttons have now disappeared and we now have a character body. Let's start by double clicking and we'll rename that to player. We'll hit enter. And then you'll also see that the inspector has changed as well. So the inspector is basically where we can change all of the built-in variables and little changes that we can tweak to the player. You'll see also in here that instead of empty, it's changed to unsave. So let's start by Control S for save. And you'll see that it's already pulled the name from here into here and it's called it player. So we can hit save. And now this scene hierarchy, which only has one node in it at the moment, has been saved as a scene in the file system. And what's really cool is if I close this window, if I hit X and go back to the window we already know, I can double click on this scene to reopen it and re-edit it. Awesome. So you'll see that there's a little yellow exclamation mark. So if we click on it, Godot is actually giving us an error, but it's telling us how to fix it too. And it's telling us that the node has no shape. So it actually doesn't know how big the object is and how it can collide with other objects. It tells us to add a collision shape node to define the shape of the object. So let's do that now. So let's right click on our player and we'll add a child node. And this opens up the menu that we already have seen. Now, moving with the error, we know that we need to add a collision shape 2D. So let's search for collision shape. And you'll see that collision shape 2D has been added for us. So let's double click on that. And that adds it as a child of the root node here. Cool. So we can see the error from the player has now gone, but we also have an error on the collision shape. So let's click this, and it tells us that a shape must be provided to function. This is really easy. So let's click on the collision shape, and then we'll go over to the inspector, and then instead of empty, we want to actually fill it with a shape. So let's select a circle shape 2D. So let's click on empty, and let's click on circle shape. And if I scroll to zoom in, you'll see that a blue circle has now been added. And this will act as the zone that the player occupies. So this zone will bump into objects, which we can use later. So let's hit Control S to save, and this gets rid of the little asterisk here, telling us that the scene has been saved. And a collision shape doesn't render in the game. We don't want the player to see this little blue sphere. It's going to sort of break the immersion of a game. So this player is actually going to appear invisible for now. So what we need to do is we need to add a sprite or a picture that will be displayed to the player. So if I open up the workshop assets and go to sprites, characters, and still, and I open this up, we'll see all of the characters you can create. Now you can use any character you'd like. I'm going to use Gary because I like Gary. And we can just drag him straight from the file system into the window. And you'll see that a new node has been created for us. So Godot automatically has noticed that this needs to be a sprite, and it's created it for us. Another thing you'll notice is that the sprite is very blurry. This is common in all game engines. It'll try and blur the sprite just to make it a little bit more in line with human vision. Because our game is pixel art, we want our sprites to be crisp and clean. So let's go over to the project settings. So we'll go project settings. And then we're going to need to look for texture. And then default texture filter, we're going to change it from linear to nearest. And if we close the window, we can see that automatically the pixel art is now crisp and clean. Let's move this sprite to the middle by just selecting and dragging it. And another thing you'll notice is that our collision shape is gone, and we can't see it anymore. That is because Godot renders objects from the top down. So it renders the character body first, even though there's nothing to render. It will render it first, and then the collision shape, and then the sprite on top. Now we don't want the sprite on top for our purposes, we want the collision shape on top. So let's just drag this there, and we'll rearrange it a little bit. So now the sprite is on top. And now we'll see that the shape is now on top, and we can adjust this really easily. Another thing we need to fix is that the collision shape doesn't lie on the character's feet. So this means that when it will be rendered in the game, the feet will actually clip underneath the terrain, which we don't want. We want the feet to stand on top. So what we can do is we can move the sprite to sit a little bit higher up so that the feet align with the bottom of the circle. So we can do this using the move tool, which is selected here, and we can drag the green arrows to move up and down. Control Z to undo. But what I'm going to do is I'm going to open up the transform in the inspector. So with the sprite selected, I'm going to go to transform. And you'll see a bunch of different movement options that we can change. So if we increase the X by holding and dragging, we can see that as it increases, you go to the right. And then if I change the Y to 2, we'll see that it moves up. Except not really. This is a little quirk with Godot 2D, and that's that as X moves to the right, X becomes positive, which we've seen already, so it increases as it goes to the right. But as we go up, Y actually decreases. And that's because it uses a computer rendering approach, where the top left of the screen is 0, 0, and the bottom right of the screen is the largest number. So we can see that as it increases X, the number will increase, and then as we go down, Y will increase. And we can see this here on the ruler on the left. So for our purposes, what we need to do is actually move the Y position upwards. So we actually need to go negative. So let's change this to -2. And we can see that it now moves up and fits nice and snug into the onto the feet. Let's hit Control S to save, because we need to make sure we're saving as much as we can. And the last thing we need to do with our player is add a custom script, because at the moment it doesn't do anything. So let's add a script. Selecting the player, we can see that this add script icon has been shown. So let's click on this. And this is the window that we use to create a script. So you'll see character body 2D basic movement. This is the template that we're going to use. And then we can just say, keep it named as player. We don't have to change any more of this. We just hit create. So a lot of code has just been added. And it is quite a lot. Don't worry about it. We will be modifying this a little bit later. But basically what this script does is it allows the player to move left and right and then jump using the spacebar. This is all we're going to need to make for our character at the moment. So let's go back to the 2D view. Let's hit Control S to save. And then we need to create an environment for the player to run around in. So let's hit the plus icon. And we don't need to make a scene that has physics on it. We just need to create a basic 2D scene that holds all of our nodes. So let's go for a basic 2D scene. Double click and we'll rename this to level. Let's hit Control S to save. And then let's just save it with the name of level. Easy. So this level will be the container that stores all of our environment, our player, all of the coins that we'll create, the enemies that we might spawn, and then the flag at the end as well. Let's fold this folder up, and let's drag the player scene directly into the world. And we can see that all of the stuff that we've made on this window has now been created here. So now you can see that a scene is essentially just a blueprint for a bunch of nodes that we can easily create in another scene by just dragging and dropping. Let's test that the player script works by playing the game. So if I go to the top right, there's a whole bunch of different projects for running the project. Sorry, different buttons for running the project. So if I hit on this one here, it says that no main scene is defined. So usually in a game, you want the main scene to be the main menu. Basically, it's the first scene that a player will see. For now, we're not going to have a main menu, we just want to play in the level. So with the level selected, we'll just go select current. And this opens up the game window, and we can see immediately that the player has fallen directly out of the world. So the gravity on the player does work, but there's no platform for it to stand on, which makes it quite hard to test whether or not the movement works. So what we're going to do is we're going to create a... Oops, sorry. Let me get rid of that. We're going to create a special platform for the player to stand on. So if I right-click on the level, let's add a child, and we'll get rid of our search. And unlike the character body that we've used already, we want a body that doesn't obey physics. So if I look up body 2D, we'll see a bunch of different bodies that we can use. We've used the character body already, but this is for gravity, so we don't want to apply gravity to it. We can select rigid body, but this moves with physics. And again, we don't want to apply gravity to it. We want a body that remains static. So Godot tells us that it can't be moved by external forces like gravity. So this is what we want. So let's select static body and let's hit create. You'll see a yellow error. This is the one that we've already seen. So let's add a child node. And let's add a collision shape. We have this yellow error, which we've already seen before. Let's create a new rectangle. And we'll see that a rectangle has been made. Let's add a sprite so we can see this level in the game. So what we can do is we can right click and do add child node, or we can use the little shortcut Control A. I like to use this because it's very fast. So let's add a sprite 2D. We just got to make sure that its static body, like this hierarchy, is correct. We don't want anything to accidentally have the wrong parent. Now the sprite 2D doesn't have a sprite loaded into it yet. It doesn't have a texture yet. And you'll see that it's actually empty. So what we can do is we can drag the little Godot icon directly across the window into this texture field here, and just drop it into that blue box. And we can now see that the sprite has now been loaded. Let's drag the sprite above the collision shape so we can see the size. And it's quite faint on the recording, but you can probably see that the shape has now been added. So what we can do is we can use these red handles to drag the shape out so that it fits around the entire sprite. So let's do that. And if you hold Alt, we can drag all 4 corners out at the same time and just drop that there. Let's select the static body, select the move tool, and then we can just move this underneath the player because we want the body to fall onto the player. Let's go back to the select tool. Let's hit Control S to save. And now let's play the game. And there we go. So now we can move left and right using the arrow keys and the space bar to jump. And there we go. Game complete. Well, not really. We're going to need to obviously add a lot more in order to make it in line with the video I showed at the start of this recording. Let's close this window. Now that we have this working, let's modify the player script a little bit more because it's not perfect. Let's click on this little script icon to open up the script window. And this is the same script that we've seen before. Let me close this output window. Let's give this some space. If you want to increase the window size of the script, the script editor, you can select distraction-free mode, as Godot calls it, which closes all of the other windows. Or if you really wanted to, you can select this icon, which pops the script editor out into its own window. So this is really great for if you have multiple monitors and you want to have the engine on one side and the script on the other. Let's just close this window and let's reopen it using this. So let's modify the player script a little bit. Now the first thing I want to do is make these variables, speed and jump velocity, visible in the inspector, right? Because we can change a whole bunch of variables here really easily, like we've already seen the transform that we can change really quickly. But what would be really cool is if we can expose these variables to the inspector. So basically telling the editor, hey, I want you to take these variables and make them available to be manipulated in this window. That might be a bit confusing, but once I get it started, you can sort of, once we do it, it'll be pretty clear as to what we've done. The first thing I'm going to do is change speed from being a constant. So a constant basically means that once it's been defined, you can't change it. So to demonstrate, I can change speed. So speed is equal to 200. And you'll see that Godot has given us an error. It cannot assign a new value to a constant because it's already been defined as 300. We can't change it to 200. So let's delete this and let's change it from a constant to a variable. So we can change it to var for variable. It's a nice red. We can actually see that a couple of variables have already been made elsewhere in this script. So let's change both of these to variables. And now this way, now we can say speed is equal to 200, and Godot doesn't give us an error. Let's make it so that we can see these variables in this inspector window here. So what we need to do is export the variables from the script into the inspector. I'll say that again. We're going to export the variables into the inspector window. So we can do this by using so the key, and then export. We can see that it's already autofilled it for us. So if we double click, it autofills, and then we'll just hit space. And it's a nice orange there. It's got our variable, and we can see that on the right, our inspector now has access to the speed variable, and we can change this without affecting the script. Let's do the same for jump velocity. And we can see that that is now added. So if I change this to something really slow, like 10, and hit enter, if I hit play now, and move, we can see that the character is very, very slow because it's been changed from 300 all the way down to 10. We can change this back to 300 by typing it in here, or by just pressing on this little arrow here. This sets it back to the default value that we've defined in the script. So by exporting variables, it makes it really easy to change values without modifying core behavior. This also means that these variables are now independent depending on the node. So to demonstrate, I'm going to drag a second player into the script, into the level, sorry. And we can now adjust the speed variable independently between the two players. So let's change this one to 10, but leave this one at 300. So if I hit play, we can now move, and we can see that the first player moves slowly, but the second player moves fast. Let's just hit the delete key to get rid of our second player, because we don't need that around. We only need the first one. And then let's reset the variable there. So you can probably see how easy it can be to make a whole bunch of nodes that still have the same behavior, but are slightly different. Cool. Let me just check my notes. Right. There's one more thing I want to modify in this player script, and that's this comment here. So you can place comments in Godot using a hashtag, and then the rest of the line will be a comment. And whoever's made this script has left us the handy comment that says, as good practice, you should probably replace the UI actions with custom gameplay. And that's what I want to do. So Godot has given us default UI actions that are used to navigate menus, such as like main menus or settings menus. And this is really great, but it's quite rigid. You might have, when you first played the game, tried to use WASD to move around, and nothing happened. That's because UI left and UI right are only tied to the arrow keys. So what we're going to do is we're going to define our own inputs with our own keys so that we can have our own actions. Let's go to Project, and then to Project Settings. Let's ignore the general settings, and let's go straight to Input Map. To show you those UI actions, we can change this checkbox, the toggle to true, make it blue, and we can see all of the UI actions it's given for us, and we can actually see UI left and UI right are given for us. I don't want to modify these, so I'm just going to hide them. Let's add our own actions by selecting the Add New Action field, and let's go left, and then we can hit the Add button, which now adds it as our own action. We now need to define keyboard keys for those actions. So this will tell the engine that this action is pressed because of the keyboard key we've pressed. Let's hit the plus key, which brings up the configuration menu, and we can drop down and we can see all of the keys that we can use, or we can select filter by event and hit the left is A, so let's hit A, and it's auto-filled it for us, so we can just hit OK. Now I also want the left arrow key to do it as well, so let's press plus again. We'll press the left arrow key. It's auto-filled for us. We just hit OK. So if you're working a little bit ahead, you've probably done this already. Let's add a right action. And let's do the same thing, but with different keys. So let's use the D key, and then we can also use the right arrow key as well. Now don't hit enter, because enter is going to override this field. Enter is going to override the field. So we just want to make sure that we don't hit enter, and we just click the OK button. Let's also, finally, add a jump action. And we want to attach this to the space key, to the W key, and to the up arrow as well. Great, so now we have all of these input actions that we can now use in our own code. So let's close this window. And let's change this from UI left to left, and we'll see that it's auto-completing for us. So we can just double-click to left. We can do right, double-click to autofill. And the last thing we'll change is UI accept, and we can change this to jump. Control S to save. And now if we press the play button, we can now use the arrow keys, the W key to jump, WASD, we can use all of these keys to move our player around. Great. Let's now create an environment for our player to run around in, because this box is quite boring. Let's right click on the static body and let's delete it because we don't need it anymore. In its place, we're going to select the level, Control A, and we're going to use a tile map. So if you've ever played a game like Mario Maker, you'll see that all of the tiles used to make the level align to a grid. And we can do the same thing in ours. So we can define a grid where we can just paint what objects and tiles we want to include. So now we've created our tile map. We can see that a new window has opened up at the bottom, but it has no tile set resource. So what we're going to do is we're going to click on the tile set, the empty field up here. Let's click it, and let's make a new tile set. And we can see down the bottom that a tile set window has been added. So what we're going to do, we're going to use the tile set to set up the tiles that we want, and then we're going to use the map as a sort of atlas to draw the tiles into the world. So the first thing we're going to need to do is set up our tile set. We're going to need to define an image that our tile set pulls from. So let's go to the workshop assets and we'll fold it down. We can fold this and we can open up the tiles and we can grab the tile map and just drag it onto this window here. This might cause a couple errors if we select yes, so let's just select no. And if I zoom in a little bit, the first thing you'll notice is that there is a bit of blank space here. So we've got tile, 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 and then nothing, even though there's still should be a bit more tile here. Now this is because Godot has assumed that our tiles are 16 by 16, when in reality our tiles are 18 by 18. So what we can do is we can go to texture region here, we can click on that, and we'll change this to 18 by 18. And now we can see that all the tiles fit really, really snugly. So what we can do is we can now select, and we can just now select all of the tiles that we want to use. So we can just select all of them for this. Another thing you'll notice is this little orange box that lies in between the tiles. Now we actually want this to lie snugly alongside the yellow border. And again, this is because it is assuming our tiles are 16 by 16. So what we can do to change this is we can go to the top right to tile set, we can click it, and we can see that tile size is 16 by 16 as well. So let's change this to 18 by 18. And we can see now in our tile set window that the orange boxes now lie really snugly. So let's go to tile map. And we'll see more or less the same window. But now we can select a tile, and with the pencil selected, we can now start drawing our world directly into the game. we can use the rectangle tool to just create a large rectangle. And then we can also use the fill tool here to just fill in the space. So let's really quickly create a world. So I'm going to use this tile. I'm going to select the ruler tool. So this creates a straight line for us. Hit Control Z because I don't need it there. And let's create a line across here. And whenever we paint a tile on top of another tile, it'll override the existing one. So let's use this one to add a corner. Let's add some corners. And let's add this one. This one. You can also, when you select the pencil, you can select the eraser as well. And you can just get rid of tiles that we've already made. Awesome. So now if I hit the play button, the player falls directly through the world again, just like it did at the start. Why is this the case? Well, this is because our tiles at the moment are just sprites, and they don't actually have any collision on them. What we're going to need to do is set up that collision. So what we're going to need to do is we're going to need to tell the tile set to define some physics layers for our terrain to operate on. Yes, that's a bit technical, and I do apologize if that has gone completely over your head. Let's open up tile set. Let's go to physics layers, and let's go add element. And then this shows collision layers and a collision mask. Now, this is where I need to explain collision real quick, because it can get a little bit confusing. So, a collision layer is a group that physics bodies can belong to. So the terrain can belong to physics layer 1, or 2, or 3, or multiple at the same time. And the mask is what layers the object can see. So currently all of our objects lie on physics layer 1 and can see other objects on physics layer 1. I actually want to change this so that terrain lies on physics layer 2. So let's select physics layer 2 and let's uncheck 1. We're now going to need to tell the player to recognize collision layer 2. So let's go to the player scene by hitting this little clapboard. We can select the player, open up the collision window. Oh, wrong one. There's two collision windows. This collision window, which shows us a very similar menu. And then in the mask, we want to select layer 2. Control S to save. And still, our player falls through. This is because each tile has not been told the shape. This is really similar to that yellow error that we had when we were first creating our player. Let's go to tile set. And instead of using setup, let's go to paint. So this way we can paint properties directly onto the tiles. So let's select a property, and then let's select physics layer 0, which corresponds to this item here. I'll click it. And this is the shape. We don't need to modify any of these variables here. We can just start painting directly onto the tiles. And this makes it nice and blue. So finally, if we hit play, there we go. So now our tiles obey physics, and we can create whatever world we want with physics enabled. So we can create a whole bunch of platforms and stuff. What I'm going to do is I'm going to have a bit of a free roam session. I'm going to drag this at the top. Sorry, I should have done that earlier, where the tile map lies underneath the player. And let's sort of have a little bit of a free roam session where we can create whatever world we want. So I'm going to unselect the eraser. And then let's put that here. Now you can make your world whatever you want to do. Whatever you want. Yeah, you can make your world whatever you want. Imagine some like Bob Ross music over the top. You can make whatever world you want. Make it a happy little world. And then I might add a platform up here. Actually, I can use this one and this one. Doesn't have to look perfect either. Cool. So that's just a little bit of what we can make. So if I now hit play, we can see that we now have a full world that we can run around in. Now, let's fix this real quick. So what we can do also is we can use the select tool to drag a bunch of tiles and then just move them up really easily. This will allow us to just duck in between this little gap. Perfect. Perfect. Oh. You didn't see anything. Cool. Let's move on by creating some coins for the player to use. So, unlike what we've done so far, our physics bodies will collide against each other and knock against each other. What we need to now do is we need to now create a scene which will allow for physics bodies to move through them instead of just simply colliding with it. Let's hit plus, and let's use other node. And the node type that we're going to use is an area 2D. So this is a region of 2D space that detects other collision objects entering or exiting it. And this is what we want. We want physics objects to move through each other. Sorry, to move through the coin and not actually bump against it. So let's hit create. This is the same area we've had before, so let's add a collision shape. Let's make it a circle because circles are coin shaped. And the last thing I'm going to do is I'm going to add the coin sprite. Just right there. And then let's make it in the center by pressing the little button there. Let's also shrink this collision shape down so it fits the coin a little bit better. We'll just grab the handle and we can just drag it down to there. Let's double click this and rename it to coin. And then let's Control S to save it as a coin. Perfect. We're going to now need to define custom behavior so that the coin knows what to do when a player collides with it. To add custom behavior, we're going to need to make our own script. With the coin selected, let's press the script add icon. Yep, and you're going to need to use node default as your template. It's going to be the coin script, and let's just hit create. Now, Godot has created two functions for us in our default template. The ready function, which runs right at the start of when the node is first made, and then the process, which runs every frame. So if you've heard of frames per second in a game, This process runs every single frame. So if you can imagine your game runs at 60 FPS, this function, will run 60 times a second. However, we're not going to use either of these methods. So let's highlight them and just hit backspace to delete. What we actually want to do is run some custom code whenever the player touches the coin. We need to use some form of event system so that when the player touches the coin recognizes that and runs code. This is a core part of Godot, and it's called signals. Now, a signal is essentially an event that fires off that says, hey everyone in the scene, something just happened and I'm emitting this signal out to everyone. Now what's really cool is that other nodes can listen to or subscribe to these events so that whenever that signal is emitted, other nodes can say, I recognize that your signal has been emitted, let me run some code. What's also really cool is we can connect signals to the node that emitted them in the first place. So that's what we're going to do. So with the coin selected, let's go to node. Sometimes it doesn't show, so let's just select coin again. And we'll see all of the default signals that's been created for us. So whenever this event happens, we can now connect it to this script to run some code. Now, the player is a character body, and we want to detect when it enters the area. So we can go to body entered, this one here, and just double click it, which brings up the connection window. We want it to connect to this one here, so just hit connect. Let's clean up the white space a little bit, and we can see that a new method has been created for us. So now whenever a body enters the area, the signal will fire and the coin will detect its own signal and then run this method. So we can test this by writing a print statement. So let's write print. Let's add some brackets, which makes it a nice purple. And let's go player has entered my area. Actually, let's say player has entered coin, just so we know what area it is. Control S to save. And now let's go to the level. Let's go back to the 2D view. And let's just drag a coin directly into the world. Control S to save again. And let's hit play. So now, whenever the body enters the coin is going to emit its own signal. The coin is going to also detect its own signal, and then it should print out the statement in this little output window down here. So here we go. And then there we go. So we can see when the player connected with the coin, the method fired just as we want it to. Now, if we open up the debugger, it has shown us a yellow error. Now, yellow errors in Godot are basically the engine saying, hey, just letting you know that this might not be what you intended. It's not going to break the game, but here is an error that might occur. And we can see it's telling us, if we click on the error, it takes us to where the error has occurred, and it says that the body has not used. And that's true. We haven't used this variable anywhere in this code, and we're not going to either. So we can tell the engine ignore this by just putting an underscore in front. So now if we hit play, we don't get that yellow error anymore. And it doesn't affect anything, but it's good to just get rid of them as you go so that we don't fill up our output window with a whole bunch of errors that don't matter. We now want it so that when the player touches a coin, the coin will destroy itself, unloading itself from memory, and not showing up again. So what we can do is we can add a new line, and we can use the queue free method. But what does this method do? Well, Godot is really handy in that it actually provides all of the documentation for our code in the editor. So if I hold Control and then click on Q3, it opens up a new window in the script editor which contains the documentation for all of the built-in methods. So it actually says that this node will be deleted at the end of this frame. And this is exactly what we want. So I'll just close that by middle clicking. Let's save it. So now when a player connects with the coin, it'll print the statement and destroy the coin as well. And there we go. Let's get rid of this print statement by simply just adding a hashtag. So this makes it a comment, because we don't need to see this print statement, but we can keep it in the code if we wish. Awesome. The next thing I'm going to do really quickly, switch to 2D, is I'm going to create a blank node in the level which will be used to store all of our coins. Because if we add a whole bunch of coins, we can see that a whole bunch of new nodes have been created. Now this is going to be really hard to manage if we have 100 coins, and you'll see 100 different coins down there. What would be really cool is if we can make a node that stores them all so that we can just fold them and don't worry about them until we need them. So let's select the level and we'll do Control A, and let's just use a basic node. We'll just click on the white one. We can rename this to coins, and then let's select our coins, hold Shift to select all of them, and then let's drag them into the coins. So now we can just fold that and ignore it. We can still move the coins independently, but now we have a sort of storage system for folding it. So let's place some coins around in the level. Let's place it there. And you can place your coins anywhere you wish. It's your level. I'm just going to have 4 for now. Let's Control S to save it. Cool, so let's recap. We've now just made some coins that the player can now touch and destroy. We're going to worry about having a score system later, but there's one thing I want to do now, and it's been annoying me since we first started, and that's that the camera doesn't move when the player does. If you've ever played any platformer ever, the camera moves with the player. So let's do that now. So what we're going to do is we're going to add a camera as a child of the player. By adding it as a child, we're going to make it so that when the parent moves the player, the children will move with the player too. So let's select the player, Control A, brings up our menu, and let's add a camera 2D. Let's go to the inspector. If we zoom out a little bit, you'll see this new pink rectangle has been added. This is our new camera. So we can see now also the camera will move with the player. But not quite. It kind of looks like the world is moving around the player, and the player is moving around the world, instead of the player moving around the world. We can fix this by adding position smoothing. So let's open up position smoothing, and let's press enabled. Now if we hit play. Cool. So you can now see a bit of lag, which adds a lot more, I want to say realism, immersion, a bit more of a playfulness to the camera, which makes it easier to see movement. Let's increase the zoom by going here to zoom, and let's increase it by 1, so we'll change it to 2. We'll see that the camera rectangle has shrunk, and then we can also see that the Y has changed as well, and that's because of this little link here. So these two variables are linked. If we wanted to break them, and let's say change them independently, we can. I'm not going to, I'm just going to leave those as linked, because I like to change both of them at the same time. Let's also offset the camera and move it up a little bit. So if I just drag this, to the left, which moves it up, let's make this like -50. And there we go. That's much, much better. But there is a little problem, and you might see this on your device or in the recording, but the player is a little bit jittery. So you can see the player sort of buzzes around a little bit and lags. That is because if we open up the player script, the player movement operates in physics process. Now it's a little bit complicated, but in a nutshell, computers will operate using process, which we've discussed before, and physics process. This is because computers have a harder time calculating physics, and it is highly dependent on the speed of the machine you're using. So physics process caps the amount of times that all this can be processed per second. So this is set at a hard limit of 60 frames per second, while regular process runs as fast as the computer can go. So currently, the player is operating at a slower rate than the camera, which is operating every single frame, which can lead to a bit of jittery. We can change this by selecting the camera and changing the process from idle to physics. So now this operates under physics time, the same as the player. And we can already see that works a lot smoother. Perfect. Just going to check my notes real quick. Okay. Let's create a scoring system which displays the amount of coins that you currently have. What we're going to need to do is firstly add a UI overlay over the front. So again, if we look at a Mario game, see if I can find some, there we go. So you can see in the top here is the UI, and it stays at the top of the screen at all times. Regardless of where the camera is or where Mario is on the screen, this UI will always remain at the top of the screen. We can mimic this by using a canvas layer. So if I Control A on the level, and let's search for canvas layer, and we'll create, and this creates a layer that lies above the rest of the world. There's no items in the layer yet, so we can't see anything. But what we're going to do is we're going to create a label which stores text. So if I Control A for and then search for label, and you'll notice that this is now green instead of the usual blue and white that we've been working with. You might have seen it already, but Control is all green, and this is for UI. So this will include buttons, it includes sliders, it includes text as well. So while blue is for 2D, red is for 3D, and green is for UI. Let's add a label, which is green. Double click that, and we'll see it appear in the top left here. Let's call it coin count. Let's change the layer to UI. And then let's change this text to coins 0. Let's also increase the size of the text by adding some new label settings. We can open this up. We can go to font, and then we can increase it to, let's say, somewhere like 60. Now, this text does look a little low resolution, and this is purposeful, because once we hit the play button, you'll see that it's nice and crisp and clean. Yeah, so just keep in mind that even though this looks a little bit low resolution, when you play it in the game, it will upscale it. let's write another custom script that will be used to track our the amount of coins, as well as update the label to show the current amount of coins. So let's select the UI. Let's add a new script. Let's leave it at just UI, and let's just hit create. Cool. Let's get rid of these because we're not going to need these. And let's define a variable that stores our coins. So let's define a variable, and we'll call it coins. And we want to tell the engine that we want every coin to be a whole number, because we can't have a decimal amount of coins. We can't have 0.5 of a coin. We want it to be an integer or a whole number. So let's put a colon and let's say int. And then let's set the default value to 0. Let's define a new function. So we're going to create our first custom function that will be used to update the coins variable, and then update the text. So let's add a function, and let's go coin collected. And this defines our function. Now Godot has given us a little bit of an error, and that's because it actually expects us to fill the function in. We can use pass, which says ignore everything and don't do anything, or we can define some functions here. So what we're going to do is we're going to add 1 to coins, doing coins equals coins plus 1. Now if you've done any form of programming, you probably recognize what this is. We're pulling the variable, we're adding 1 to the variable, and then we're reassigning the value. What we can also do is we can also condense this by just saying plus equals, and this tells the engine to do exactly the same thing. What we want to do now is update the label here. But how do we tell the engine that we want to update this label? Oh, we can just say coin count, right? But Godot has given us an error. It doesn't know what coin count is, but it's right there. What we're going to need to do is define a variable that stores coin count. If I hit enter a few times, what I can do is I can grab this, select it, hold control, and while I hold control, release my mouse. And what this does is it creates a reference to a child node. This onReady expression tells the engine, do not do anything with this variable until this node is ready to be grabbed. Godot will also provide an error if you don't include this. So it actually tells us to do this. Cool. So let's change this to coin count. And then we want to change the text, so we'll do dot text. And then we can change it to coins. And then we can add coins as a part of that. But not quite. Godot is trying to add a string to a number, and that's going to make it really hard. So what we need to do is we need to convert this variable to a string. So we can just do str for string, and then pop these in brackets. One thing I'm going to mention very, very quickly is that this reference is really great for making things fast, but it's a very rigid system. This is because it relies on the name of the node. For example, if I change this to coin label and hit play, an error is going to be thrown because the node can't be found. So let's change this to coin count again. What I recommend is that you export this is what we recommend, is that you export a reference to the coin count. Why is this? Because if we change the name, if we change where it sits in the hierarchy, if we change anything about it, it's still going to keep that reference. That was just for personal explanation. I'm going to leave this as this because this code should just work as it should. What we're now going to need to do is tell the UI to update the coin when a coin is collected. So if I go to the coin script, which all of these coins share in common, we can also reference a node by dragging, holding Control, and dropping that. Now we have a reference from the coin to the UI. Let's tell the UI to update the amount of coins. So let's go UI dot update. What have we called it? Coin collected. Coin collected. So now what a coin is going to do is it's going to tell the UI to update a coin when it's collected, and then destroy itself. So now, and there we go. If yours isn't working in any way, please feel free to either pause and just go back through it, or feel free to go back in the video. But now we have a way to store the amount of coins we have, which is very neat. We now need a way to win the game. So what we're going to do is we're going to create a flag, which is really similar to the coin, except when it's touched, we want to spawn a win screen. Let's hit plus and we'll create a new scene. Let's add an area. We'll rename it to flag. And let's add a collision shape. We will make it a circle. And then we will also drag the flag directly on there. And then let's make it centered. So this is all stuff that we've done in previous nodes as well. Let's save it as flag. Great. And that's all stuff that we know how to do already. So similarly to the coin, we're going to need to add a custom script. So if I hit the plus icon here and just hit create, we have the same stuff. Now we can get rid of these as well because we're going to do the same thing for the coin with the on body entered signal, and we just want it to do a bit of different behavior. So what I want to do is go to node, select the flag, and then go to body entered, and we can double click this and connect it to the flag. Exactly the same as we've done it for the coin. But how do we create a win screen, right? Could we just go create win screen? Well, no, because we don't have a method like this yet. Let's leave this as pass for now. Let me explain a core feature of game engines. So far, what we've been doing is dragging objects out of the file system and directly into the level. So what we're doing essentially is transforming these scenes into nodes. This is a process known as instantiation. And yeah, it's the process of transforming something from a scene into the node and adding it to the level. Instantiation. Now we can drag stuff out as much as we want, but we can't obviously do that in a real game. We don't have access to all of these files in a real game. We only have access to this window right here. What we're going to need to do is write some code that instantiates a win screen on the fly while the game is running. What we're going to need to do is create a new scene, let's add another node. And just like the UI for the player, let's add a canvas layer. And let's call it the windscreen. Oop. Yeah, let's Control S to save it. Let's add a new label. And let's say you win. And now let's center the label. So what we're going to do is we're going to select this little, what looks like a Super Smash Brothers Final Smash ball. Select that, and then we'll just hit middle for center. And this pops the label directly in the center of the screen. Let's create some new label settings, and let's increase the font size to somewhere around 100, just to make it nice and visible. Great. Let's save that. So now we have a scene of the windscreen. What we're going to need to do is instantiate that by first grabbing a reference to where the scene is in the file system. Because even though we don't have access to the file system when the game is running, the engine still will. So let's add some lines, and let's grab this, and holding Control, let's drop it. And you'll see this is really similar to onReady that we've used before. But instead of an onReady reference, it's added a reference to where the scene is in the file system. I'm going to write a bit of code now that might be a bit confusing, but feel free to copy and paste it, and I'll explain what it does in a second. We'll put an underscore there so we get rid of that yellow error. Let's do get tree. Whoop, turn off caps. Get tree. Actually, let's just add it as a sibling. So what add sibling does, if we go to the documentation by holding Control and clicking, it tells us that it'll add a node as a sibling. So let's, for example, let's go here to our level. All of these coins are siblings of each other because they have the same parent. So by when the flag adds the windscreen as a sibling, it'll go just underneath the flag here as if it were like this. So this is what it's going to do in the real game. Let's just delete that, because we don't want to say you win at all times. Where is our unfinished code? Let's go back to add siblings, and let's go windscreen. But this is still a scene. We want to instantiate it as a node. So let's go .instantiate. So this transforms the scene into a node, and then adds that node to the tree. Awesome. So now if we hit play, and we run over to our flag, if I touch it, it'll now create a windscreen. Now, there's obviously an error with this, and that's that we can still move, and we can still jump, and we can still do whatever. Let's make a script on the windscreen that will be responsible for pausing the game and then reloading the current game when we add a restart button. So let's add a script. We're not going to use process, but we are going to use ready. Let's get rid of this comment here. Let's get rid of this line here. And let's add a comment that says pauses the game. And what we can do is we can use get tree, which gets all of the nodes in our tree. And it's got a variable called paused, and we can just set that to true. So now, if I go to the flag and I touch the flag, the game now pauses. And I can't move, I can't jump, I can't do whatever. Lovely. Let's add a button to the windscreen that'll be responsible for restarting. So if I add a button, child node, let's put this in the center. Let's use the move tool to move it down a little bit so it doesn't overlap with the title. Let's go restart. And we can increase this font size. Actually, let's just leave it. Let's just leave it. This is fine. Move it down even further. There we go. So the button also has a signal on it. So if I move the window out, not scroll. If I select the button, it also has its own signals on it. Now we want to use the pressed signal for when a button is pressed. So let's double click on this. And we want to connect the signal to a function that we're going to make in the windscreen. So let's hit connect. And we can see that this new function has been made. Now what we can do is we can reload the current scene by doing getTree.reload current scene. Perfect. Let's test this by playing the game, and we can win. And now if we press the button, nothing happens. Why is this? Well, quite simply, we've paused the game. Everything is paused, including this button. So even though it highlights and even though it looks like it's being clicked, it's actually not running any code because it's currently paused in the game. Let's make it so the windscreen can't be paused by the editor. So let's select the windscreen. Let's go back to the inspector. And in process, let's change it from inherit to always process. So regardless of if the scene is paused or not, the windscreen will always run. So now, I should be able to click the button, which will reload the current scene. Perfect. But we can't move yet. Why is that? Because we never told the game to unpause. So let's just... Actually, let's write some comments. Go reload. And we can really simply just copy paste the code. But instead of true, we just want it to say false. Awesome. So now, if we win, we can now select the restart button. Oh no. I think this needs to come first. I think we need to unpause it and then reload the scene. Yes, that was it. So you need to unpause it and then reload it. My apologies. Cool. I also want to add a color overlay. I've just realized that the text kind of just appears. Let's add a color rectangle. So let's Control A. Let's add a color rect, which is just a rectangle with a solid color. Let's put it at the top because we want it to lie behind everything. Let's anchor preset. We can set it to the middle or the left, or we can go down to the bottom right and it says full rectangle, and that fills the entire screen. And then let's just change this to a nice gray with a little bit of transparency. This doesn't do anything functionally, but it just makes it nice and easy to see easier. Perfect. Okay. You guys just made a complete game. So if you haven't given yourself a pat on the back, please do it now. I'll wait. Cool. Now that we have a way to win the game, let's also have a way to lose the game. So we want to make it so that when the player falls outside of the world, then that's game over. Let's create an area in the level. Actually, got a better idea. Let's press the plus icon and let's create an area here. And let's add a collision shape. Let's rename this to kill zone. But we don't want to add a shape to this. and I'll explain why later, but let's not add a shape or a sprite to this. What we're going to do is we're just going to add functionality. So let's add a new script. We'll call it kill zone. We'll create it. And let's get rid of these methods here. Let's make it so that when the player enters the kill zone, it will run some functions. So let's go body entered, double click, and we'll just connect it there. Let's hit Control S to save. Now, there is a few things that we're going to do. We're going to copy paste the win screen, because the win screen functions exactly the same as the game over screen, just with different text. So in our files, let's go to win screen, let's right click, and let's just duplicate it. Let's duplicate it, and let's call it game over. And now if we go to game over, let's open that up. Let's change this to game over. We can change this text to say the same thing. And then what you might have to do is disconnect the button signal and rig it to the same thing. It's going to be a bit confusing, just follow along. So we're going to right click and disconnect, and then we're just going to connect it to this script here. Cool. I've realized I've now made the script a bit confusing because I've named it win screen, but we're also using it on the game over screen. So we can rename it by going to winscreen.gd, gd being the names of our scripts, and let's rename it to end screen. Because that's a little bit, strips it back a little bit, makes it a little bit obvious to see. Let's go to our level, and let's drag the kill zone scene into the level. Let's put it there. Now what we want to do is we actually want to give it a shape here. Let's right click on kill zone and go to editable children, because we can't see the shape at the moment. And then what we're going to do is we're going to override the existing shape with a new one. Now what we could do is we could create a rectangle and stretch it really far out. That is probably a bit too much work to do by hand. So let's instead use a world boundary shape. Let's reposition that. Now what this does is basically the same thing. It's going to create a collision area infinitely along the left and the right axes. Even though it doesn't look like it, that is what it does. And this should still function just fine. So if I drop down here, I've come across an error. Oh, I haven't even done any of this yet. Okay. Cool. Let's pretty much copy exactly what we've got for the flag. Actually, let's do that. Let's just copy what we've got on the flag. Control C to copy, and then Control V to paste. The signal name is the exact same, so it works just fine. Let's change this to game over screen. Let's change this to game over screen. And then it's still got a reference to the win screen, so I'm just going to drag. We don't have to hold control. We just drag it straight in. And then there we go. So now that should work. So now if I fall off the bottom of the world, there we go. And this functions the exact same as the win screen. Easy peasy. Cool. So now there is a complete game that's been made. So well done, everyone. But there's still a little bit more we're going to do. I'm sick of looking at this grey. It's a boring grey colour. Let's make it a nice blue. What we can do is really similar to the UI. So the UI is a canvas layer, which lies on top of all of the nodes. Let's define a background that lies underneath all the nodes. So let's select the level, Control A, and let's do a background. So it's really similar to the canvas layer, but instead of lying on top, it's going to lie at the back. Let's add a color rectangle to this. And then let's increase this to the full size, or the full rectangle of the screen. Let's go to the inspector and let's change the color from white to like a nice light blue. Save it, play it, and there we go. So that's a nice little light blue for us, and it looks a lot better than the boring gray. Let's close all these up by middle clicking because we're not going to need these. I like to keep my top bar as clean as possible by having as little scenes as possible. The reason I've left the player is because we're going to work on him a little bit more. So let's make it so that the player is now animated when they move left or right. So far, this is just a basic animated sprite. What we can do is we can change the type so that it keeps its position but changes the type of node. So let's right click on the sprite and let's change it from a sprite to an animated sprite. And we can see that the Gary that we used before has now completely disappeared. This is because we haven't set any frames up for it. So let's select this. Let's go to animation and let's select some new sprite frames. If we click on this, it now opens up a new window for us to use. So let's rename this state to idle. And then we're going to create a new state, one for idle and one for run. So let's create a new run state. Let's worry about the idle state first. This one's going to be really, really simple. We're just going to grab the still one and just drag it straight on. And because this is just the one sprite, we're not going to worry about modifying anything else. For run, we're going to need to do a couple more things. With run selected, let's click on this little 3x3 grid. And then let's navigate to the sprite sheet that shows our running. Right, so it's workshop assets, sprites, characters, and then in the sheets is there. So let's select Gary sheet and let's open that. And we'll see this new window. Hold control to zoom in. There we go. So now we can see this new window, which displays all the frames. Now this is really similar to the tile map, where Godot has assumed the wrong amount of tiles. So it's currently got 16 tiles. We don't want 16 frames, sorry. We only want 2. So what we can do is we can go to the left and say that, no, I only want 2 horizontal frames and then 1 vertical column. So there we go. So these now sit nice and firm. So let's click to select these and we'll add 2 frames in. Awesome. In order to preview this animation, let's press the play button just here. And we can now see that it animates really nicely. It's a bit slow, so let's change this from 5 to 12 FPS. We'll just hit enter, and then there we go, we can see that it moves a lot faster. Let's change it so that the idle animation is the default one that is created, because we don't want it to, when the game first starts, the character is not moving. So let's make idle the default one. So what we can do is we can press this little autoplay button, and that goes a nice blue, and that says to the engine, I want you to play this animation first. Simple. we're going to have to modify the player code so that it plays the right animation when we do the right actions. So let's go up to the top, let's add some space, and let's have a reference to our animated sprite here. So let's grab this, hold Control, we've done this before. Yeah, we'll just leave it at that. We don't need to rename it. Now what we want to do is we want to make it, firstly, we want to flip the sprite the right way. Actually, let me think. Okay, first thing we're going to do is we're going to have it so when the player is running, then we're going to play the run animation. This is conveniently in these 4 lines. So direction is for when the direction of the player input is more than 0. So this is when the player is moving. Actually, let's write some code here. Let's write some code here just to make it nice and easy for us to read. Right, and let's tell the engine to animate the run. So let's go Gary still, because that's the name of the node that we've used. And we can do .play. And it auto shows the 2 animations that we've made. So this is when we're moving, so we want to do the run animation. And then similarly, we can just copy paste the code if we wanted to. We want it to play the idle animation. Save that. And now if we hit play, it automatically does the idle animation when we're not moving. But now when we move, we now run. And then when we stop, it stops animating. The problem now is that Gary always faces left. Let's make it so that Gary faces the direction that he's moving in. We can use the velocity variable, which stores the current moving direction. So velocity.x will be positive if the player is moving right. Now what we can do, if we go back to our 2D view, select the animated sprite, and then go to offset, there is this flip horizontal toggle that we could turn on and off. And that makes the frame change left and right. We can modify this variable in code, so we tell it, I want you to now turn to the right or face the left. If Gary's moving to the right, velocity.x is greater than 0, which we want to be flip h is true. So follow along with me. Let's go if velocity.x is greater than 0, so it's moving right, we want Gary still dot flip h is equal to true. And then otherwise, so else, we want this to be false. Perfect. So now if we're moving right, Gary will face right, and now when we're moving left, Gary will face left. Perfect. And that works just how we want it to. Okay. There's 2 more major things that we're going to worry about. That is audio and then an enemy that we can make. Now the enemy is going to be the hard one, so I'm just going to ignore it for now, and let's worry about creating some audio. So as shown before, we do have a bit of audio. And we want this to play at certain times. Let's start with the coin sound. So what we want to do, actually, let's start with the player jump. I think that's probably going to be a bit easier. We need to have a new node that is responsible for playing audio. So let's add a new node, and let's look up audio. And there's a couple nodes, but the one we want to use is audio stream player, not the 2D one. because we don't want it to come out of the left and right channels independently. We just want it to come out of both left and right at the same volume. So we'll just add a basic audio stream player. Let's change it to jump. And we're going to need to assign an audio stream so it knows what file to play. So let's just drag the jump sound effect into there. Save it. And now what we want to do is whenever we jump, we want this audio stream player to play. Luckily, we can do this in the handle jump if statement. So let's just drag it straight in. Dot play. Perfect. So now whenever we jump, perfect. This is going to be really, really similar for these other sound effects. So let's get cracking. The UI will be the one that's responsible for the coin sound effect. Why is this? Well, we've already told a coin that when it is collides with the player, it should destroy itself. This will include any audio stream player node that is connected to the coin. So it's going to both play the sound and destroy itself at the same time, which is effectively not going to play a sound. Let's have it instead so that the UI plays the sound, because we know that the UI will always be present. So the same thing, we'll add an audio stream player. Let's call it coin sound. Let's assign the MP3 directly into the field there. And then in our coin collected function, let's do the exact same thing. We'll play a sound that will tell the player, hey, you've just collected a coin. Awesome. Alright, the last two are the winning sound effect and the losing sound effect. So really similarly, let's go to the win screen. Let's add an audio stream player here as well. Let's call it win sound. And let's apply the level complete sound to there. And then let's play it in the ready function. Oh, actually. Dot play. Alright, there's going to be an error with this. So if you can spot it now, good job. But there's going to be a little error with this. Let's go to the game over screen. Let's add an audio stream player. Let's call it game over sound. And let's add game over to there. Perfect. So now if we press play, we can now jump, collect coins, and now when we win, we should hear the win sound effect. Awesome. And now when we lose, oh no. Remember how earlier I said that node references are very rigid and they rely on the names of the nodes? Well, the game over screen doesn't have a win sound, it has a game over sound. So what I recommend, and we've said this before, is we export a reference to the win sound. So let's make it an audio stream player. And let's instead call sound effect. Right? So now, when we select the game over, let's assign the sound effect to this variable. And then we'll need to do the same for the win screen too. So while green node references are really good at getting stuff done quickly, it is also very rigid. So if you need to change anything about your node hierarchy, it's probably going to break your code. But now that we fix that, when we lose, and then it should still work if we win. Perfect. What we're now going to do is create an enemy that moves left and right. Where's the level? It'll sit in this little hole here. It'll move left and right, and it'll sort of flip directions and sort of bounce when it hits a wall. This is going to more or less be a test of everything we've learned so far. Let's start by creating a new scene. We don't need it to obey physics, so let's just make it a basic 2D scene. Let's rename it to enemy. We're still going to need to define an area in which the player can collide with. So let's create an area. Let's create a collision shape to go with it. Let's make it a circle. And there we go. Let's also create a new animated sprite. We're just going to skip the static sprite and just go straight to animated sprite. Let's define some new sprite frames. Click it. Now the beautiful thing about the enemy is that it always moves. It's only got one animation on it and it'll always play them. So let's auto play this. And now let's select some frames. So the 3x3 grid. And we'll select Spikester Sheet PNG. Control and scroll to zoom. And then let's change these frames as well, because we want 2 horizontal and 1 vertical. Let's click on these frames and let's add them in. Okay. Let's make the area sit a little bit more snug within that. There we go. So now if the player connects with any of this area, it will lose the game. Oop. Control S to save. Let's save it as an enemy. I'll just be 1 second, sorry. I just got a bit of construction outside. I don't know if anyone can hear that. Anyway, let's add a script. Actually, I realized something. Let's get rid of this area. Why? Because we want it to have the same behavior as the kill zone when you drop from the level underneath it. So what we can do is we can grab the kill zone and drag it directly onto here. Now remember how we didn't define a shape in the basic kill zone scene? That is because if I turn on editable children, I can now select a circle shape, and it now has the exact same logic as the other kill zone in the main level. So now we adjust that. Let's also change this to 12 frames. Okay, awesome. So now what we want is we want the enemy to move to the left, because we want it to move in the direction it's traveling. So let's add an enemy. What are we going to do? Let me think for a second. Let's store the current X direction. Let's say -1. Oop, that should be an equals, not a colon. In the ready, we're not going to need a ready. And then let's also define a speed that the enemy can move at. So let's have an exported speed. Actually, let's make this a float, because we want it to be a decimal number that we can change. Let's start by putting an underscore here. Actually, we're not going to need to. Let's change the position of the node over time. So let's go position dot x, because we want to change left and right movement. And we want to add to it x direction multiplied by speed multiplied by delta. Now, if you don't know what delta is, basically, a computer can render a lot of frames a second, like a lot of frames. But this is dependent on the computer. See, my big beefy desktop computer can probably render a lot more frames than my grandma's Chromebook. This means that if we increase the position by a set amount every frame, because I'm rendering more frames, it's going to go further than a lower end computer. What delta does is it makes the variable independent of the frame, or frame dependent or independent. Basically, it means that if we multiply it by delta, no matter the speed in which the computer is operating at, the position at the end of 1 second will be the same distance apart. I would highly recommend watching a video on YouTube, which will explain it a lot better than I can. Anyway, let's save our enemy. Let's go to the level. And let's drag our enemy into this little hole here. Now if we hit play, we can see that the enemy moves. And actually, the player has collided with the spike in game overs. So on the plus side, we know that that works too. Let's now have it so that when the enemy collides with this wall here, it will turn around and move the other direction. What we're going to need to do is introduce what's known as a raycast. Now, a raycast is really similar to an area, except it shoots in a straight line and is invisible as well. We can do this in a node by Control A, and let's add a raycast 2D. And we want it to shoot in the direction that's currently forward. So let's select this. We can drag the handle so that it is just in front. So now we need to tell it so that when the raycast collides with terrain, it will turn around. First thing we're going to need to do is change the collision mask. Now remember that our terrain lies on collision layer 2. So let's change this to 2, and let's not have it recognize 1 anymore. We only want the raycast to recognize collision layer 2. Let's hop into the enemy script. And now we'll say if, and now we want to check if the raycast is colliding with anything. Is colliding. Actually, let's move this up here. And we'll write some comments in a second. We want to change the X direction. We want to flip it. So we can multiply it by -1. Cool. So if the raycast is colliding with the terrain, so now if I hit play, there we go. So if you can see it real quick, the enemy then bounces off, but then kind of gets stuck into the wall. And the reason that is because the raycast is still facing left. So what we're going to need to do is sort of flip it so the raycast then faces to the right. Just going to hit Control Z to undo that. What we can do is if I select the enemy and then go to transform, let's unlink this, because what we can do is we can make this -1, which flips the whole thing around. And that's what we want to do. So let's also and scale. So let's do scale.x, and let's also make this multiply by -1. So now, let's try that again. So now we can see that our enemy now moves left and right, And then when I collide with the enemy spike, I lose. Perfect. Okay, so that's now it. That is more or less the complete game. The only thing I want to add now is a way to exit the game without having to click the X. So what we're going to do is use a different Godot feature called an auto load. Now, an auto load is basically a script or a node that lies above the level. So it doesn't matter what happens in this level, an auto load will lie above it in the hierarchy. Let's right click here and let's create a new scene. Let's make it a basic node and let's call it the exit manager. Call it the exit manager. Now we want this exit manager to always work regardless of whether the game is paused or not. So let's click on this. Let's go to process and we'll hit always. So now this exit manager will always operate, so we can now leave the game either on the winning screen or anywhere we want. Let's add a script to the exit manager, which will handle exiting the game. So yours should say no default. So I'm going to create. We don't need the ready function. We are going to use the process function, but we're not going to use delta. So let's just put an underscore there. And now what we want to do is we want to check if the exit action is pressed and then close the game from there. So let's go if input dot is action just pressed, and we don't actually have an exit action. So let's really quickly set one up. So if you recall, right at the start of the project, we'll go to project settings, input map, and let's create an exit action. And let's just tie this to the escape key. Very simple. So now let's go exit. So now when the exit action is pressed, we want to exit the game. So we can tell the game to quit by just using getTree.quit. Perfect. We also need to add the exit manager somewhere in the game. So let's go to project, project settings, and we've had general, we've had input map. Let's go to auto load. Let's hit this little folder icon, which displays what we can add. It's pretty much everything. Let's add exitmanager.tscn to our auto loads list. And then we'll just hit add. So just to demonstrate, if I press play and then go here to the remote, which shows everything currently in the level, we can now see the exit manager is now created and it lies above the level. And it also means that if I hit escape, that just works. Awesome. Last step, very, very last thing, is we're going to export the project. So this way we're going to have an executable file, which we can take wherever we want. Let's go to project, export, and we need to tell the engine what kind of platforms we want to go for. So let's hit add. And these are all the platforms that Godot can currently export for. Now, unfortunately, it can't export to consoles just yet. That is because consoles are closed source in the way that they export, which doesn't exactly jive very well with the open source nature of the engine. It is being worked on at the moment. So let's click on Windows Desktop. I'm sorry if you're on Mac. I'm not quite sure how to export it properly, but there is a YouTube tutorial for it. So I am sorry if you are using Mac OS. I'm going to be using Windows. So let's hit Windows. And you'll get this red error that says that there is no export template found. Because the engine needs to be... Because they've made the engine as lightweight as possible, they've purposefully not included any export templates for platforms. So we're going to hit Manage Export Templates, and we're just going to hit Download and Install. This might take a little bit of time. So we can just wait real quick. I guess while this is loading, I might go through a couple quick tutorials about some really cool pre-made tutorials on Godot. Or not. The download seems to be throttling my internet connection at the moment, unfortunately. Oh, sorry. Yeah, I guess as you can see, the template for Windows is a lot larger than the engine itself. Whereas other engines, Unity for example, will have you download the export template with the version that you're using. This can make it really convenient for like a one and done kind of thing, but it means it's a little less flexible if you decide to make a project that doesn't export to Android or something. It should also be noted that when you download the template, you don't have to download it ever again. This is just a one-off thing. Perfect. Okay, let's close this window and let's go back to project and export. All right, we don't have this error anymore. Lovely. We need to define an export path for the executable to go to. So let's hit the folder icon. Now you can put this anywhere. If your project is on a desktop, it'll likely be on the desktop as well. So let me really quickly go to my desktop as well. Okay, maybe not. All right, one sec. Alright, cool. So once you've selected a folder, you just need to write the name of your file. And then the only thing we're going to change is this variable here. So in order to have it work properly, it's going to export an executable and a PCK file. And those need to be together, otherwise it's not going to work. What this checkmark is going to do is it's going to embed the PCK into the executable, so it's only the one file. So let's just turn that on. And then let's just export the project. And then let's turn off export with debug. And then we'll just hit save. And that's it. So now, if I just find where I've actually put these, see. Right. So now you can open up where that folder is. And that's just right there. So there you go. So that's your executable. And if you open that up, you'll see the exact same game that we've just made. Perfect. That ends the tutorial section. So pats on the back to everyone. Give yourself a round of applause if you've made it this far. I apologize if anything was a little bit confusing or fast. Feel free to, I guess, pop a comment down below if you found anything confusing. And I'm more than happy to help you out with anything. Let's hop back into these slides. So what's next? Learning there's a whole bunch of things you can do in Godot. The UI system is particularly robust. And once you figure out how to use it, it can make really nice looking UI and menus. Godot also has really easy implementation of shaders for making custom visual code. Also learning how to make a web build, because it'd be really cool to make a game and pop it on itch.io. As well as just learning the general quirks of GDScript. And for that, I would highly recommend the Bracky's tutorial about GDScript, where he goes through all of the different things you can do in it. It's a little bit more advanced than this tutorial, but I highly recommend it. Now, before you go, stick around. For those who actually attended the workshop, there should be a feedback form that should have been emailed to you. Please fill that in. It makes it easier for us to figure out how we can better run these workshops next time, as well as how to run Tech Fest better as well. And we've got one final announcement, which is just an advertisement. But, as I mentioned at the start of this video, we've been developing Arcane Raiders over the course of the past couple of weeks, and it has been shown off at the UTS Tech Fest. And we have been very excited to announce that it is now available to wishlist on Steam. That QR code will bring you to the landing page where you can wishlist the game. And we're very, very proud of this game. It was all made in Godot. It has online and local multiplayer enabled, so it's very far in development. So we'd very much appreciate you just checking it out and playing it. Yeah, if you wanted to get in contact with us at any time, here is our link tree where you can come and follow us. You can come and follow us on the Team Stingray Discord server under these @. But yeah, thank you so much for watching this recording and sticking around, and a special thank you if you showed up to the workshop. It was very fun. It was very exciting. We hope you learned something either from that workshop or this recording, and happy developing.